Okay, here we go. That number affects the period. That number affects the period and either stretches this graph horizontally or shrinks it. That's got to be terrifying. Okay, the first one, let's go down here and just talk about what the period is. So the period is going to be not 2 pi divided by our number, but pi, because the period for tangent is pi. Pi divided by 1/2. I'm going to flip, and I'll multiply pi by 2, and so my period for this function is 2 pi. However, I want you to write, and I want you to know, it's centered at 0. Look, the original function, it's centered at 0. It goes to the right up, it goes to the down left. So if I stretch this thing, instead of having a period of 1 pi to 2 pi, I'm going to leave the 0 in the middle, and I'm going to move everything out accordingly. So the asymptotes are going to move. Okay? If I start at 0, and normally I have an asymptote at pi over 2 and negative pi over 2, that's only pi. I want this period to be 2 pi. So doesn't that mean I got to go pi to the right and pi to the left? I'm going to put a vertical asymptote at negative pi. I'm going to put a vertical asymptote at pi. And as a result, that distance is pi. So is that distance. This period is now 2 pi. Leave it centered at the origin and move it out or bring it in accordingly. Okay, and so where would the next one be? If this is a 2 pi distance and I'm at pi, well, it won't be here. It'll be all the way out here at 3 pi before I put another vertical asymptote. So I can have another 2 pi in between my asymptotes. And if I'm going to go left, I'm not going to put this vertical asymptote at 2 pi because that's only a distance of pi. I got to go past this and go out to negative 3 pi so that when I put my vertical asymptote at negative 3 pi, I have another distance of 2 pi. I'm now going to graph 3 periods of the tangent function. The zeros are just right in the middle of those things. So from pi to 3 pi, the middle is 2 pi. And from negative pi to negative 3 pi, the middle is 2 pi. Or you can just see it visually. And then make yourself a wider tangent graph. That is a horizontal stretch. I took that function, I stretched it out. Leave the period, the first one, centered at 0. Take half of the period and go that way. Take half of the period and go that way. So you got the whole period centered on 0. Okay, the last one kind of sucks. The period is going to be pi divided by this number right here, 2. Pi over 2. That's it. That's the whole period. You guys, that's the distance. I'm going to be drawing some skinny little swooshies right in here. Now, it's also centered at 0. So if this is going to be pi over 2, I got to go half of pi over 2 to the left and half to the right, and that is pi over 4. So I got to land this vertical asymptote in this space in between 0 and pi over 2. And another one in between 0 and negative pi over 2. Look how skinny this tangent function is going to be. So since my period is now just pi, pi over 2, that's 90 degrees, I'm going to get another vertical asymptote every 90 degrees. And so every one of these open spaces in here represents 90 degrees. So look at how many tangent functions I'm about to draw. Now the zeros will be in between them at all of these spots, pi, 3 pi over 2, 2 pi. And then let's draw some skinny, little tiny tangent swooshies. There you go. Little tangent swooshes everywhere. This is a horizontal shrink because when you multiply things times x, it's backwards. So by multiplying by 2, I actually horizontally shrunk it or compressed it. All right, I'm going to try and find some good problems for you on my math lab to do with that. I'm not going to make them too complicated, but that's how you graph the tangent function. Big weird day. Have a good day.